Okay, so hopefully you have pulled this up. So in my opinion, when it comes to something that's very dry and also important, one way to make it much more interesting is to provide these little worksheets where students connect the dots before I tell them the answer. A lot of times the really good students get annoyed because I'll ask them really hard questions, but usually students end up really liking it. And I always tell them, worst case scenario, you get stumped, and then it's an incentive to pay attention to me, right? But I try to set it out for these, I see, oh, I see. Whereas if I just threw up the graph and explained it, that would be the most boring class in the world. So let's go through the answers. If there are diminishing returns to labor, and you can see the way I usually do this is I don't even describe diminishing returns yet. If you add one more worker, the additional product produced is less than the additional product that came from adding the previous worker. And then we look down here, when do diminishing returns take effect? Well, it says right here, right? So with the third worker. But then we kind of go into it a little more. What happens to the slope of the total product line when diminishing returns start to take effect? So let's look at that. So we've got this total product line, and it gets really steep. Okay, it's really hard to see, but it gets really steep. That's when there's increasing returns to labor. And then it becomes flatter, but it's still positive. So the marginal product is the slope of the total product line. So what happens is when there's increasing returns, the slope gets steeper right here, okay? Then when there's diminishing returns, it starts to get flatter. All right, so when is total product at its peak, and what is true about marginal product at that point? Total product is at its peak over here, looks like at 7 workers, and marginal product is 0. So again, marginal product is the slope of the total product line, so the slope is 0 at the flat point. It also just makes sense. This is the point where adding additional workers does nothing and then makes things worse. All right, so when this is an important part here. So hopefully you guys got this. When marginal product is above the average product, what is true about average product? Let's look at this. When the additional product is greater than the average, it brings the average up. So average product is increasing. When marginal product is less than average product, it brings it down. Marginal product is decreasing. Now, I like to think about the cumulative GPA here. So average product is like your average GPA, right? If you get a grade that's higher than your average GPA, it brings the average up. If you get a grade that's lower than the average GPA, it brings it down. Marginal product is additional, right? One more additional grade. So let's think about this. If each additional worker is bringing higher than the average, it brings the average up. If it's lower than the average, it brings the average down. So when average product is at its maximum, what is true about average product and marginal product? When average product is at its maximum, they cross. And that's something you're always going to see. So we're going to keep repeating this. We'll see it in the numbers, we'll see it in everything else. And actually, if I go back to, let's see here. If I go back to our original example where we've got marginal product and average product, when marginal product is greater than average, it brings it up. And then at the 5th worker, it becomes less than the average and it brings it down. So we can see that with the other example. All right. So here we go. I've got the same things. So it's worth repeating. We've got the slope of the total product line becomes steep and then becomes flat, then becomes 0, then becomes negative. That is when marginal product increases, then decreases, then becomes 0, then becomes negative. We can see marginal product and average product cross where average product is at its peak. When marginal product is greater than average, it brings it up. When it's less than average, it brings it down. Now imagine if you're teaching this, right? If students have already done the worksheet, this makes way more sense. And it's kind of like, oh yeah, I can kind of see that. It's just worth doing when we're studying something this dry. All right, So we've also got increasing returns, decreasing returns, negative returns. There we go. And here's the rule. You can refer to that on your own. All right, so your textbook becomes a little weird here. So it covers it the same way every other textbook does. And then it says, what role is the manager? And I think it's because it's a managerial economics book, so it's hyper-focused on it. What role is the manager? So this is where I started laughing. So they said, the role of the manager is to produce output on the production function. In other words, provide workers incentives to induce maximum worker effort. Okay, fine, whatever. But one of the things they talk about is profit sharing. Whenever I hear about this, I think of the movie Office Space. And I don't know if you guys are young enough where you don't remember it or never watched it, but I would recommend watching this clip from Office Space. It's a classic. Okay, so I'm actually super pumped that I can play this in all my classes from here on out. Yeah, so apparently the manager increases incentives, whatever. But the other thing is, it's really weird that it's kind of hidden in this what does a manager do portion, because this is like one of the main points of the whole chapter, okay? Which is, if this is a short run question, how many units of the input do you employ? In other words, if capital is fixed, how many workers do you hire? And it goes into the main, like it just gives away the punchline. And the punchline is, you hire labor until the value of the marginal product of labor equals the wage rate. Value marginal product of labor equals the wage rate. Or value marginal product of labor equals price times MPL, or where that equals that. Also the same thing, capital, value marginal product of capital equals R, which is the rental rate. I've never heard it referred to this way. Usually we call this marginal total revenue product, but whatever. So value marginal product. This is the value of the output produced by the last unit of an input. Okay, so we hired the last worker. What is the marginal product of labor? You just multiply it by the price of the product. How much is that worth? So if the additional pizza worker produces 12 more pizzas, you would say, well, how much revenue do these pizzas bring in? The law of diminishing returns, I guess we'll just mention it in the middle of the chapter. The marginal product of an additional unit of output will at some point be lower than the marginal product of the previous unit. Yeah, we know that by now. To maximize profits, use input levels at which marginal benefit equals marginal cost, and then they kind of talk about this rule. Super confusing the way they talk about this. So what I'm going to do is I'm going to show you the chart from the book and kind of talk you through it, and then we'll go through an example. So we've got the variable input, which is labor, and now we've got this new information, which is the price of the product. We've got marginal product of labor. They've skipped the total product column here. They just give you the marginal product. This is from table 5.1, okay? All you do is you multiply the marginal product of labor by 3. So the first worker brings in 76 additional units of product. Each of them brings in $3. So that worker is bringing in $228 worth of stuff, okay? This is what we would call the marginal benefit. The marginal cost is just the wage. Well, how much am I paying that worker? Well, I'm paying that worker $400. So here's an example of marginal analysis, which we were doing with consumer theory, but we're going to do a lot more of. So you go through each one. So the first one, all right, the first one brings in $228 and I'm paying them $400. Well, that's a terrible deal. So if it was just, you just looked at the first one, you'd be like short-sighted, because you can see if you push through the first one here, because of increasing returns, the second worker brings in $516 and you only have to pay them $400. That's a good deal. You should hire that worker. The third one brings in $732. You pay him $400. Yes, 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 yes. No, right? So we see this 10th worker here. You pay them $400. They only bring in $228 worth of stuff. You should not hire that worker. So the way marginal analysis works is anyone for which marginal benefit is greater than marginal cost, you make that decision, and then you kind of stop where they're equal or as close as you can get without the cost being higher. So it's kind of like the Price is Right. You the closest without going over. You never produce where the cost is greater than the benefit unless it's the first couple and you're like pushing through them. So how many workers should they hire? They should hire 9 workers. All right, so what I've done now, I believe we're at this point, is I've provided you with a sample problem. So pull up that sample problem and see if you can work it out yourself. All right, so hopefully you have found this practice sheet here. Make it a little bigger. All right, so basically you find this chart, which is over here. So the chart looks like this. We've got daily tuna catch. This must be tuna fishermen. It's the wrong cookbook. The price of tuna is $2, and the wage is $10,000. All right, so let's first just fill this out. So the average product of labor, you take total product divided by the variable input, which is the number of fishermen. Marginal product of labor. How much does total product change with the addition of one more worker? Okay, so we've got marginal product here. So the first thing that I ask, if I'm remembering correctly, is do we see diminishing returns to labor, and at which point do they start? Well, we can answer that. Yes, we do. They start with the addition of the 4th worker, right? So we've got increasing returns followed by diminishing returns. The next question I ask is, do average product and marginal product behave like we expect them to? Yes. When average product is you can actually see it's less than, when marginal product is greater than average product, it brings it up, brings it up. They're the same, brings it down, brings it down, brings it down. They cross at the peak, just like we would expect. So it's always helpful to do these common sense checks. Is this predictable? Does this seem to be what we're expecting? All right, so then I say, how many units of labor should this firm hire? So what we need to do is calculate the value marginal product of labor. So you take the price of 2 times the marginal product of labor, and we've got the value marginal product. Total labor cost is just $10,000, so we can just copy and paste. That does not change. So you just, basically, we don't need to fill out the other columns. You just compare this with this and say, when this is greater than this, you should hire them. So yes, 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 yes. We're on the borderline. Yeah, we might as well hire them. No, do not hire that 7th worker. Okay? Marginal labor costs, some textbooks talk about this. It's the same thing as wage. We can ignore that. And then basically you could say total revenue product minus total labor cost, marginal revenue product minus marginal labor cost, but you don't have to do that. You can just say, all right, this is the best amount of people to hire. So the next thing, hopefully my computer doesn't die, the next thing that I ask you is if the price of the good increases, what do you think will happen? All right, so if the price of the good increases, you'll probably hire more fishermen. That's what I would think. Let's recalculate the value marginal product of labor with the price of 4, and let's see what happens. All right, so in that case, you would hire 7 fishermen. And I've done this 1,000 times, so I can do it quickly in my head. But if you go through and compare anything where this is greater than this, and then stop where they're as equal as they can get without cost being higher, you get 7. All right, so I'm going to stop here, and I'll finish up with one more lecture on this week.